Sir, your video is mute. Sir, your audio is mute. I can't hear.
So, good afternoon. Welcome to class 6 of Econometrics I. So, we are working out the problems from the chapter 16, that is from the theory of estimation, and we'll continue with the solving the problems in this class 2. So, I'm starting to share the. Okay. So, it's visible. Is it visible?
Yes, sir.
So, we'll now work with problem number example 16.6. Okay. So now there are two parts of the problem. One part of the problem is this, that there is a population mean, that is mu is equal to 0.1 and population standard deviation, that is sigma. That is sigma is equal to 2.1. Okay, standard deviation. Now the random sample is of size 900. Fine. So we'll have to find the probability that the mean of this random sample, that is del x, that is x bar, is less than 0. That we have to find. Okay. Now, population mean has been given, population standard deviation has been given, and the sample size has been given, but we don't know anything about capital N, which is the population size. So this is not known to us. So we have to estimate the probability that x bar, which is the sample mean, equal to 0. So let me rewrite this one second. X bar is less than 0. That is, the sample mean is less than 0. Okay. Now, we will be using a standardized normal variable. Okay. That is x bar minus mu by sigma by root over n for this random sample. So, according to the central limit theorem, as n becomes very large, so this standardized normal variable tends to be asymptotically normal, okay, with mean 0 and variance 1. Fine. So now what we have got? So we have got mu is equal to 0.1, sigma is equal to 2.1, n is equal to 900. So this means what? This means root over n is equal to 30. So what we can write? Z is equal to x minus 0.1. Okay. This is 2.1 by 30. So x bar minus 0.1. So this is 0.07. Okay. Fine. 0.7. Done. So what is then how we can then write the variable further, the mean further, expression for the sample mean. So the expression for the sample mean can now be written as x bar, okay, x bar equal to what? So x bar is equal to, just a minute, 0.07 z minus 0 plus 0.1. Okay. So this we can write because z is equal to x bar minus 0.1 by 0.07. So we just realign the variables and wrote it. So now we'll have to find that probability x bar is less than 0. Okay. So that means we have to find the probability of what? We have to find the probability that is 0.07 z plus 0.1 should be less than 0. This means my probability 0.07 z should be less than minus 0.1. This means my probability z should be less than minus 0.1 by 0.07. Okay. So now we have to find probability that z is less than what? So what is 0.1 by 0.07? How much is it? Let us find this out. So this is nothing but 1.43. That means z is less than minus 1.43. Now since normal, so we have to assume that this standardized variable, the standardized random variable for mean is asymptotically normal. So for a normal distribution, by symmetry, since a normal distribution is symmetrical distribution, so by symmetry we can write this as p z is greater than 1.43. That is probability that the standard value of standard variable, standardized normal variable z is greater than 1.43. Okay, fine. So that means we can write this further as 0.5 minus p. So I'll give you the notes on normal distribution later in the next class. So for the timing, kindly bear with me on this. So 0.5 minus a, that is z is greater than 0 but less than 1.43. So we have to use a table to find the value of this. That is z lies. That is a probability that z lies between 0 and 1.43. So the value as per the book is given as 0.4236. So which is nothing but what? 0.5 minus 0.4236. 0.5 minus 0.4236. So this is 0.0764. Okay. So this is part A of the problem. Now part B of the problem. So the sample size now is 64 students. That is n is equal to 64. Okay. So the standard deviation. So standard deviation of the time taken by a college that takes a college student to complete a project in 40 minutes. Okay. So there is a standard deviation of the amount of time it takes a college, standard deviation of the amount of time it takes a college student to complete a project is 40 minutes. Okay. Now we have to find the probability that the sample mean. Okay. We have to find the probability that the sample mean is 8 minutes less than the population mean. So the population mean is mu and the sample mean will have to be less than a population mean by 8 minutes. That is, sample mean has to be less than mu has to be less than this. That is mu minus 8. Okay, so the sample mean. So we have to find not this one. So we have to now find what is the sample mean. So they are saying that the sample mean has to be equal to the population mean. That is x bar equal to mu minus 8. So we have to find this. That is sample mean is equal to mu minus 8. Okay, so we have to find this. That is, the sample mean is 8 minutes less than the population mean. Now again, you have to create a standardized variable z. So this is x bar minus mu, again sigma by root over n. So this is asymptotically normal as per central limit theorem, 0, 1. So what is z? Now we have to find x bar is what? Mu minus 8. Okay, mu minus 8 minus mu. Sigma is how much? 40. Number of students was how much? 64. So root over n is 8. So this will be what? Minus mu by 40 by 8 is how much? 5. Okay. Sorry, minus 8, not mu, minus 8. Minus 8. So z is equal to how much? Z is equal to minus 8 by 5. Fine. So now you'll have to find the probability. So what is the probability you now need to find? So the probability that you will have to find now is this. That is, so here I have to repeat once again. So n equal to 64, standard deviation of the time that takes a college student to complete a project is fair. So you have to find the sample mean. So you have to find the sample mean, that is x bar is greater than is 8 is greater than mu minus 8. That it is more than 8 minutes less than the population mean. So we have to find this probability. Okay. So this is the standardized normal variable. So that is it. Z is equal to this. So we have to now find what? We will have to now find this one. That is P. That is x bar is greater than mu minus 8, which means Z is greater than minus 8 by 5. Okay. Minus 8 by 5. Fine. Z is greater than minus 8 by 5. Done. So that means we will now have to write what? That is Z is greater than minus 1.6. So that means Z should be less than 1.6. So we can now write this as follows. What? We can now write this as 0.5 plus P as this. Okay. So we have to find the value of this probability that z is greater than 0 but less than 1.6 from the normal table. So the value is given as 0.4452. Okay. So this is nothing but 0.9452. So using the concept of the central limit theorem, even if a distribution is not normal or we don't know anything about the distribution of the random sample, using the central limit theorem and the standardized normal variable, that is x minus mu by sigma by root over n, we can, that is asymptotically normal, distributed normal with mean equal to 0 and variance equal to 1, we can calculate the probability of the standardized normal variable taking different values. Okay. Now, next example. Example 16.7. So there are 6 values. 1, 2, 3, 4, 5, 6. So that is a population. 1, 2, 3, 4, 5, 6. Fine. So we have to get all the random samples of size 2 without replacement. So number of possible random samples of size 2 will be given by this 6C2, that is 6 factorial by 4 factorial into 2 factorial. So we can write this as 6 into 5 into 4 factorial. This we can write as 4 factorial into 2. So they cancel each other out. So 2 and 6 cancel 3. So we have got 15 possible number of samples, random samples. Okay. Now, sample number, sample mean. One, two, three, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4. No, 1, 2, 3, 4, 5, 6. So these are the population. 1, 2, 3, 4, 6. 2. Okay. Then comes one, 3. Then comes what? 1, 4. Then comes what? 1, 5. Then comes what? 1, 6. Next, 2, 1, 2, 3, 2, 4, 2. So no, this one. So 5 samples. So next sample, 2, 3. Okay, 2, 4, 2, 5, 2, 6. Done. 10, 11, 12, 13, 14, 15. Then comes 3, 3 is not possible. 3, 4, 3, 5, 3, 6. Next one, 4, 5, 4, 6. And the last one, 5, 6. Now Now, what are the possible sample mean average of these two numbers? 1.5, 2, 2.5, 3, 3.5, 4, sorry, 2.5, 3.5, then again 2.5, 3, 3.5. 4, 3.5, 8, 4.5, 4.5, 5, 5.5. Okay. So now we'll have to find the following things. First, we need to find the population mean. One plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21 by 6, 3.5. Now we'll have to find the population variance. So, what is the total number of observations? 1 by 6. So, this is what we can write as follows. So, population variance is what? Population variance is sigma square. So, 1 minus 3.5 square plus 2 minus 3.5 square plus 3 minus 3.5 square plus 4 minus 3.5 square plus 5 minus 3.5 square plus 6 minus 3.5 square. Okay. So next we can write this as 1 by 6. So this is nothing but minus 2.5 square plus minus 1.5 square plus 0 minus 0.5 square plus 0.5 square plus 1.5 square plus 2.5 square. So this is 6.25 plus 2.25 plus 0.25 plus 0.25 plus 2.25 plus 6.25. Okay. 6.25 plus 2.25, 8.5. Then 0.25, 0.25, 0.5. So 8.5 plus 0.5, 9. 2.25, 6.25. How much? 17.5. Okay, so this will be 17.5. So this is how much? 2 point. Let's see. 2.917. Okay. Now we have to find the expected value of the sample mean. So first for that we have to find the value of sample mean. Okay. Value of sample mean. Number 1. That is x bar. Frequency F and next probability. So what are the values of the sample mean? The values of the sample mean are 1.5, 2, then 2.5, 3, 3.5, 4, 4.5, 5, finally 5.5. Okay. So how many times 1.5 is appearing? Let us check. Only one time 1.5 is appearing. How many times 2 is appearing? 1, that 2 also one time. How many times 2.5 appearing? 1, 2, 2 times. How many times 3 is appearing? 1, 2, 2 times. How many times 3.5 is appearing? 1, 2, 3. Okay. How many times 4 is appearing? 1. 4 is appearing only once. How many times 4.5 is appearing? 4.5 2 times. 4.5 is appearing 2 times. Just so how many times 5 is appearing and 5.5? 1 each. So 4 is not appearing one time, 4 is appearing 2 times. So now what is the total frequency? 1 plus 1, 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 3, 9, 9 plus 2, 11, 11 plus 2, 13, 13 plus 1, 14, 14 plus 1, 15. So what is the relative frequency which will give you the probability of the sample means, of the respective value sample means? 1 by 15. This is also 1 by 15. This is 2 by 15. This is 2 by 15. 3 by 15. 2 by 15. 2 by 15. 1 by 15. 1 by 15. So now we'll have to find the expected value of the sample mean. Okay, so which is nothing but this summation over x bar into p of x bar. So what we are getting, 1.5 into 1 by 15, 2 into 1 by 15, 2.5 into 2 by 15, 3 into 2 by 15, 3.5 into 3 by 15, plus 4 into 2 by 15, plus 4.5 into 2 by 15, plus 5 into 1 by 15, plus 5.5 into 1 by 15. Okay. Now 1 by 15 is a common term, so we take this out. So here it is 1.5 plus 2 into 1, 2, plus 2.5 into 2, 5, plus 3 into 2, 6, plus 3.5 into 3, that is 10.5, plus 4 into 2, 8, plus 4.5 into 2, 9, plus 5 into 1, 5, plus 5.5 into 1, that is 5.5. Okay. Fine. Now we will have to find the, so what is this turning out internally? 1.5 plus 2, 3.5 plus 5, 8.5 plus 6, 14.5 plus 10.5, 25 plus 8, 33 plus 9, 42 plus 5, 47 plus 5.5, 52.5. 52.5 by 15. So what do we get? Expected value of the sample mean is equal to the population mean, which is equal to 3.5. Now we'll have to find what? Sample variance of the sample mean. So for that you have to find one more term, that is E of x bar square. This is nothing but summation x bar square into P of x bar. Okay. So 1.5 square into 1 by 15, 2 square into 1 by 15 plus 2.5 square into 2 by 15 plus 3 square into 2 by 15 plus 3.5 square into 3 by 15 plus 4 square into 2 by 15 plus 4.5 square into 2 by 15 plus 5 square into 1 by 15 plus 5.5 square into 1 by 15. So 1 by 15 is the common term. So 2.5 square is how? So 1.5 square. So 1.5 square is nothing but 2.25. 2 square into 1. 2 square is 4. 4 into 1, 4 plus 2.5 square is 6.25 into 2, 12.5 plus 3 square 9 into 2, 18 plus 3.5 square 12.25 into 3, how much? 12.25 into 3, 36.75 plus 4 square into 2, 4 square into 2, that is 16 into 2, 32 plus 5 square into 1, that is 25 into 1. Sorry, 4.5 square into 2, 4.5 square is 20.25 into 2, that is 40.5. Okay, plus 5 square into 1, that is 25, plus 5.5 square into 1, so 5.5 square, so 5.5 square is nothing but 27.5 plus 2.75, that is 30.25. Okay, so let us check. 2.25, 4, 6.25 into 2, that is 12.5 plus 3 square 18, 3.5 square, that is 12.25 into 3, that is 36.75 plus 16, 4.5 square, that is 20.25 into 40.5 plus 25, 5.5, 30.25. Now, so this is now page 6. This is 1 by 15. So 2.25 plus 4, 6.25, 6.25 plus 12.5. Let us now add this up. Okay, so 2.25. 2.25 plus 4 plus 12.5 plus 18 plus 36.75 plus 32 plus 40.5 plus 25 plus 30.25. 201.25. 201.25. Okay, 201.25. So 201.25 by 15. Let us see. Divided by 15. So this gives me 13.41. Okay. So now you have to find the variance of x bar, which is this. Okay. So variance of x bar, so we already know this value is 13.41. Ex bar was 3.5, so 3.5 square. So this is 13.41 minus 12.25. So which is nothing but 1.16. Okay. Now you see population variance. Population variance sigma square is not equal to variance of x. But if you use this formula for random sample of size n without replacement, that is variance of x bar equal to sigma square by small n into n minus n by n minus 1. Okay. So what is sigma square? We know sigma square is already 2.917. What is n? N is 2. Okay. Capital N is 6. 6 minus n, 6 minus 2. N minus 1, that is 6 minus 1. So 2.917 by 2 is how much? 2.917 divided by 2, 1.4585 into 6 minus 2 is 4 divided by 5. So this is nothing but 1.484585 into 4 by 5. So into 4 divided by 5. So this gives me what? 1.167, which is exactly what we get by this, which is what we have also got already. So in case of simple random sample without replacement, okay, in case of simple random sample without replacement of size n, we'll have to use this formula using the value of the population variance, using the value of this population variance, which is sigma square. We have to use this formula for the variance of the sample mean to calculate the value of the sample mean, which is what we got here also, 1.16. So the 7 part is not appearing, so that is an adjustment which is happening, some adjustments up to 3 decimal points. So this is what we get. Okay. Now, if you want to calculate the variance of a random sample of size n with replacement, what is the formula? That is sigma square by n. What is sigma square? 2.917 by 2. So which is nothing but 1.4585. So what do we find? We find variance of sample mean with replacement is greater than the variance of sample mean without replacement. Okay. So SR, a simple random sample with replacement variance, is greater than the variance of the simple random sample without replacement. Okay. So the last problem which we will solve now. Vigyan, are you feeling sleepy? Vigyan, are you feeling
Sir?
sleepy or tired?
Sir? Sir,
Okay, very
nothing.
good. That means you can now study for 2 more hours. We can have 2 more classes.
Sir, no, not like that.
Huh?
Sir, my charge will finish. My charge will finish.
So you'll charge your finish. So you don't have power or what that you cannot charge your phone.
Sir, no, actually. I have to go somewhere after this class.
Okay. So yes. But is this class convenient the way I'm doing it?
Sir, yes.
So
Sir,
you're
you will again
getting.
send a recording in the Google Classroom, right?
Yeah, I'm sending the recording. YouTube link you are getting, no?
I'm going through every day after lecture. I'm going through the recording once again. Then
So
after that, it is clear.
it is clear, no?
Yes.
So better than classroom.
Sir, yes, better because we can hear the recordings now. That's why.
Yes, that is good. So simple random sample without. So now we'll have a. So there is a random sample of size 8. Without replacement. Okay. Random sample of size 8 without replacement. So n is equal to 8 and this is SRS WOR. What are the observations in the sample? Observations are 46, 08, 38, 24, 35, 29, 36, 40. Okay. So there are how many students in the class? There are, so the population size is 18. Okay. Out of which you have randomly drawn 8 students and looking at their marks. Okay. So these marks are out of a total marks of 80. So the full marks is 80. Sorry, full marks is 50, not 80. And the subject is mathematics. Okay. Subject is mathematics. Fine. Now we'll have to find the total marks of the class. Okay. So we have to find the total marks of the class. So we have to estimate it. And then we'll have to find the variance of this estimate. Have you looked at the book yesterday, S.C. Gupta?
Sir, yes.
Okay. Now, we will be using this relation, that is, the expected value of the sample mean is a consistent and unbiased estimator of the population mean. Okay. That means whatever sample average we'll get from this marks of 8 students, we can take it as a consistent estimate of the average marks of all the 18 students. Okay. Now, what is the sample mean? Sample mean will be 46 plus 0.8 plus 38 plus 24 plus 35 plus 29 plus 36 plus 40 divided by 8. Okay. So 46 plus 8, 54 plus 38, 92 plus 11, 116 plus 35, 151 plus 29, 180 plus 36, 216 plus 40, 256 by 8 equal to 32. Okay. So now the estimate for the population mean will also be 32. So what is the total marks? Total marks will be nothing but capital N times, that is the population size, the population mean, which is 32 into 18. Sorry. 18 into 32, which is equal to 576. So now we'll have to find the variance of this estimate, that is var n mu. So since sample mean is a consistent and unbiased estimate of population mean, so we can write this also as variance of n x bar. So this can be written as using the formula, that is var of ax equal to a square var of x. So we'll write this as var of n into x bar is equal to n square into var of x bar. Okay. Fine. So now n square variance of x bar. So for a simple random sample of size and without replacement, what is the variance of that sample mean? Variance of the sample mean is given by this formula, that is n square into sigma square by n into n minus small n by capital N. Okay, small n by capital N. Now n and n square cancel, so we have got n, so this can be written as sigma square n sigma square by n into n minus n, but here sigma square is unknown. So for the unbiased estimator of sigma square, you can use this formula, that is sigma square equal to 1 by n minus 1 into summation of x minus x bar square. Okay. So we can use this formula. So we can now, so this is nothing but equal to capital A square. So we can now write this as n by n into n minus n into capital A square. So this is nothing but n by n into n minus n into 1 by n minus 1 summation x minus x bar whole square. Okay. So I'm not getting into the details. You look into the calculations which are provided in the book. So the formula is like this. So n is capital is now 18, small is n. So this is 18 minus 8 into n minus 1, that is 8 minus 1, 7. And this term is 970. Okay. So simplifying further, 18 by 8 into 10 into 1 by 7 into 970. So they cancel each other out. So this is 4, this is 5, these again cancel each other out. This is 2, this is 9. Okay, they cancel each other out. So this is 485. So 9 into 5 into 485 by 7. Okay, this gives me how much? Let me check it. So this gives me 311.857. Okay, so this is the variance of the sample mean, variance of the estimate, not the sample mean, variance of the estimate, that is the population estimate which we have made. Now we'll have to find the standard error of this in, which is nothing but this variance of, okay, so what is this? This is nothing but root over 3117.857, and let us see what is this. So this is nothing but 55.837. Okay. So one more problem left. I was sorry, extremely sorry. One more problem is left. So I think you can do it yourself. I am giving this as an exercise. Do it yourself at home. Page. So this is example 16.9. So what is it saying? That there is a random sample of 10 numbers. So n is equal to 10. So this is simple random sample without replacement, SRS WR. So what is this? Population. Population is the number 1, 2 till 100. Okay. So you will have to find the variance of the sample mean. Okay. So we already know the formula. So first what you have to do is as follows. First you have to find the variance of the population mean. Sorry, variance, not population mean, variance of the population. So you have to find the population variance. Okay, which is sigma square. Then you have to find the variance of the population mean, which is nothing but the formula sigma square by n into n minus n by n minus 1. So where n is equal to 100, first 100 natural numbers. Okay. So you find the population variance. So the formula for population variance for first 100 natural numbers is given by this. That is sigma square in this case will be k. First 10 natural numbers will be k square minus 1 by 12, where k is first in natural numbers. So there are first 100 natural numbers. So what is sigma square? Then will be sigma square will be k square will be how much? 100 square minus 1 by 12. So this will be quadruple 9 by 12. Okay. Quadruple 9 by 12. Fine. Now you have got the sigma square. Now you have to put the formula here. I have already done it, so you don't have to do it. So here we have already got sigma square, quadruple 9 by 12 into 1 by n, that is 10 into 100 minus 10 by 100 minus 1. So into 1 by 10 into 90 by 99. So this comes to as 9. This will So this is 1, 1, quadruple 1, and this will be 11. Okay. So again, you cancel this. So 3 3s are 9, 4 3s are 12. So we get what? Into 3 by 4 into 11. Okay. So this is nothing but how much? Variance 100 minus 10. That is 90 by 99, 999. Okay. So you simplify this and then you get the answer. Okay. So that's what we have for today's class. So I'll send the video recording. I have also sent the recording for the morning class. I
Yes,
have also
sir.
sent the recording for the morning class. I've
Yes, sir.
uploaded it.
I'll see.
Check it. So I'll also send the recording of this class. Okay. So have a nice evening. Thank you.
Thank you, sir.